Alright, so try to read the problem yourself. Okay, so first let's state the given. So I'm going to write the tree in this order so we could fit the solution part very nicely. Okay, so first let's start with the given. So we have an area which is equal to 2.3 centimeters squared. So the area is already provided. We don't have to look for that anymore. Next we have electric field, which is 1.23 times 10 raised to 4 newtons per coulomb. Alright. Then we have an angle from the normal line according to the problem. That means the angle given is already phi or phi, which is 63.5 degrees. Okay? So knowing those, we can immediately conclude that the required, of course, as per the lesson, is electric flux. Okay? So this is electric flux, don't forget that. Okay, and then our equation would be electric flux is equal to E cosine phi area. So don't confuse uppercase Greek letter phi to lowercase Greek letter phi. Alright, so this is for the value of the electric flux and this is for the value of the angle. Okay. So next, let's solve for the unknown. So for our solution, just substitute the values. Okay, so electric flux is equal to, so this would be electric field first, so that's 1.23 times 10 raised to 4 newtons per coulomb times cosine 63.5 times, what's our area? So that's 2.3 cm squared. So as you can see, our area is not in base SI. The base SI for distance is meters, so area should be meter squared. So we're going to calculate for that first. Okay, so okay, let's take this one first. So centimeter squared can also mean 10 raised to negative 2 meters times 10 raised to negative 2 meters, correct? Okay, so that's equivalent to cm squared. Okay, so since this is what we're dealing with, okay, so let's change this to parentheses. Okay, so you multiply the multipliers and then you multiply the unit, so that's 10 raised to negative 4 meters squared. Okay, that's cm squared for you. Then we're going to substitute this. Okay, this value here. Alright, so what's going to happen is, okay, I'm gonna move a little bit here. So that would become, and while we're at it, let's change this to base SI as well. So that would be 1.23 times 10 raised to 4 kilogram meter per second squared divided by coulombs times cosine 63.5 times 2.3 times 10 raised to negative 4 meters squared. Okay, I hope you've taken notes of this. I'm going to erase this now. So we could have our space. Okay, so let's rewrite this. Times 10 raised to negative 4 meters squared. Okay, so we have let's return this to newtons. Actually, we don't need to convert that. Okay, so check. You're going to notice you don't have to actually cancel any units, so just plug in the values to your cycle. Okay, so do it like this. So I'm going to input it first, then show it to you. So that would be 1.23 times 10 raised to 4 times cosine 63.5 times 2.3 times 10 raised to negative 4. Alright, so it would look something like this. Okay, just wait for it to focus. There you go. So our answer would be there, 1.26. You don't have to write 10 raised to 0 because that's actually equal to 1. So our answer is 1.26. So copy all the units. So Newton times meter squared is Newton meter squared. Then you have coulombs at your denominator. So this would be the value of our electric flux. So box your final answer so that I could see it on your solution sheet. Alright. So for the second problem, we have the first given, which is we have a charge that has an electric field of 4.5 times 10 raised to 6 newtons per coulomb. Okay, then it was placed on a circular surface that has a diameter of 3 centimeters. Alright, and then we have an angle coming from the normal line. Again, this is already phi, which is equal to 33 degrees. Okay, so for our required, we have electric flux, of course. Then for our equation, we have electric flux is equal to E cosine phi area. Okay, so right from the bat, we're going to see that the area is not given, right? But instead we have the diameter of a circular surface. So what we're going to do is derive an equation using, of course, the formula for the area of circle. So let's do that. So area of the circle is pi r squared, correct? Okay. But then again, the given is diameter, not radius. But we know that diameter is equal to radius times 2. Correct? Then to obtain radius, we divide both sides by 2. So cancel. Right? So we will have r is equal to d over 2. So let's substitute that to the equation, and you're going to have Okay, let's try to put it here. So you're going to have electric flux is equal to E cosine phi. Area natin would be, instead of pi r squared, that would become pi d over 2 to be squared. Get that? Okay? Then, after that, you can immediately proceed on substituting. So, for our solution, we have electric flux is equal to 4.5 times 10 raised to 6 Newton per Coulomb. Okay? Times cosine 33. Okay? Then we have the area of a circle, which is pi times, so what's RD? 3 centimeters over 2. Then this is to be squared. Okay? So first, let's operate on the centimeters by converting it to base SI. So that would be in meters. Then let's try to do that. Okay, so that, write the equation. So times 10 raised to 6 newtons per coulomb times cosine 33. So then this would be pi times, so this would be 3 times 10 raised to negative 2, since 10 raised to negative 2 is centi, correct? Meters over 2, okay, to be squared. Okay, then let's place the parentheses here. Then after this, you can now actually put the values in your cycle. Then that's it. So let's try to do that. Okay, so 4.5 times 10 raised to 6 times cosine 33 times, so that's 3 times, oops, make a fraction first, so that's 3 times 10 raised to negative 2, okay, over 2 to be squared. Then of course, don't forget your pi. Right, so I'm going to show you the equation. It must look something like this. There, so 4.5, that's our electric field, times cosine 33 times the area of the circle, which is pi r squared. So this is the diameter over 2 to be squared times pi. So the value for that would be there. So we're going to keep up to the hundredths place. So 7 is the thousandths place, so that's round up. Okay, so our answer, that would be 2.67 times 10 raised to 3. So our unit, so just multiply all the units, so that would be Newton meter squared per coulombs. Alright, so this would be your electric flux. So that's our final answer, and that's it. Okay. Okay, for our third example, let's have the given. So we're looking for the electric field, so let's write the flux first. Okay, electric flux is, it looks something like this. It's equal to 5.96 times 10 raised to 3 Newton meter squared per coulombs. So we have an area which is equal to 2.6 cm squared. And then we have an angle from the normal line, so that's phi, which is 32.5 degrees. Okay, so according to the problem, the required for us to look for is the electric field. Okay, then for the equation, of course, we have starting from this one, so that would be E cosine phi A, correct? But since what we need is electric field, we're going to have that remain on that side. Okay, so what we're going to do is divide both sides by, let's write this somewhere here. Okay, so let's divide both sides by cosine phi area, so same here, cosine phi area. Okay, so this would cancel out this and this. Okay, so that would mean that our final equation would be electric field is equal to electric flux over cosine phi area. Alright, after that, let's proceed with the solution. So we're just going to substitute the values at this point. So for our solution, we have electric field is equal to, so what's our flux? 5.96 times 10 raised to 3 Newton meter squared per coulombs over, so we have cosine 32.5 times, we have the area 2.6 cm squared. Okay, but this cm we're going to change it to meter squared since this is not the base SI, right? So we're going to change this to meter squared. Okay, so what we're going to do for that is rewrite so this is 2.6. Okay, so let's grab cm squared. So that is equal to cm times cm, right? Then centi is 10 raised to negative 2, correct? Times, so don't forget the unit. Okay, multiplied by 10 raised to negative 2. Okay, so that would mean cm squared is equal to, so multiply this, that would be 10 raised to negative 4 meter squared. Then substitute this to cm squared. Okay, so let's do that. So I'm just going to erase this. Okay, so that would be 2.6 times 10 raised to negative 4 meters. There you go. Then after that, you can input now those values to your cycle. So let's do that. So by the way, don't forget that this is in squared before inputting the values to your cycle. Make sure that you have cancelled the unnecessary unit. So we have meter squared here and here, which will confirm our unknown or required, which is electric field, since the remaining unit is newtons per coulomb, the unit of electric field intensity. Okay, so let's do that. So let's input that on our cycle. So that would be 5.96 times 10 raised to 3 divided by cosine 32.5 times 2.6 times 10 raised to negative 4. There. And to show you our answer, that would be 2.71. Then the next number is 7, so that's round up, correct? Okay, so final answer would be 2.72 times 10 raised to 7. Right, then don't forget the unit, that would be newtons per coulomb. Okay, then box your final answer. Then that's it. Okay, for our fourth problem, so the given for that, we have a radius. Alright, so this time we are given a radius, so that would be 4.89. The unit is in centimeters. Then we have an electric field of 2.72 times 10 raised to 7 newtons per coulomb. Then we have an angle from the normal line, so that would be phi, which is 42.6 degrees. Alright, our required for this problem is electric flux, and our equation would be E cosine phi times the area. Then from the problem and from the given, we can see that the area is not provided, but we are told by the problem that the surface is circular in shape, so we're going to change this to the area of a circle, so that would be E cosine phi by r squared. There. Then after that, we can now substitute the values. So for our solution, we have an electric field which is 2.72 times 10 raised to 7 newtons per coulomb times, oops, we forgot this one. Okay, so don't forget that, guys. Alright, so we have electric flux equal to the value of the electric field times the angle of the electric field, so that's cosine 42.6 times, so we have pi, then we have 4.89 cm squared. Okay, so you have to square this first. Okay, but before that, let's convert this to base SI. So let's write that. So that would be 2.72 times 10 raised to 7 newtons per coulomb times cosine 42.6. Okay, so I'm going to use bracket here because we're using parentheses here. So this is 4.89. This would become times 10 raised to negative 2 meters to be squared. There. After that, you can now input this to your cycle. Alright, so let's do that. So that would be 2.72 times 10 raised to 7 times cosine 42.6 times pi. Then of course you put another parenthesis, 89 times 10 raised to negative 2. That would be squared, then another parenthesis. Okay, so for our answer, so I hope you can see it. Okay, let me adjust the focus. There. So let's return here. So I hope you saw that. So that would be our answer. So as you can see, there would be no cancelled units, so that would be 1.50 times 10 raised to 5. Then just copy the units. So we have Newton, so you're going to square meters here, so that would be Newton meter squared. Then you have coulombs here, then that would be the value of the electric flux. That's the final answer. Then